My name's Martin Wakeman, and welcome to the Cartoon Guide to Asset Management. First of all, what is asset management? But before we can understand how we manage assets, we first have to work out just what is an asset. The term asset means different things to different organisations. ISO 55000 says that an asset is an item, thing or entity that has potential or actual value to an organisation. So, an asset could be an organisation's people, or the collective knowledge held in the organisation, the reputation of the organisation, its brands, its processes, the way it does business, its documents, its history, financial assets, reserves, capital, the company's contracts, or it could be more physical things like warehouse stocks, production machinery, its equipment. We don't manage all these assets in the same way. Some of the ideas I will explore today can be found in my booklet EAM for Beginners, available on Amazon. For the next part of this presentation, I'm going to use a diagram on the front of this booklet. I use this honeycomb diagram extensively when discussing asset management with clients. I find it very useful. It's a representation of the capabilities required in a particular industry. In this case, it's a nuclear generating company, but a similar diagram can be drawn either in this honeycomb form or some other format. This particular diagram, being just for a nuclear generator, doesn't have much up here on customer management, but has a lot around here on safety management, as you'd expect. The diagram contains within it the management of many of the assets mentioned previously. Over here are people assets and their training. Up here are documents. Over here are supply chain assets, and up here are operational assets. But at the core of the electricity generating industry, as with the oil and gas industry or water utility or manufacturing plant, are the physical assets, the equipment items or tags or plant items, whatever they are called in your industry. In the nuclear industry, they are called systems, structures and components. Basically anything that may require maintenance or monitoring or modification in order to keep the plant moving. In this video, I'm going to address this part of the diagram, the maintenance management of the physical assets. I will explore how you develop an appropriate maintenance strategy. I will look at defect management, preventative and predictive maintenance. In later videos, I will address the other aspects of this diagram. If you can't wait for the other videos, I suggest you read my book. In any industry that relies on its machinery, whether they are manufacturers, water utilities, electricity generators or distributors, oil refineries or oil rigs, there is a simple equation. Whilst the machines are running, the organisation can make money. Whilst the machines are stopped, then the organisation loses money. All machines or components need maintenance. Some machines or components are more important than others. Some components may fail without affecting the smooth running of the machine. Each component needs to be identified, and its importance will determine the maintenance strategy to be applied. The simplest strategy that can be applied to any equipment item is run to fail. Put simply, let the equipment run until it fails and then fix it. This is a legitimate strategy if the equipment is not vital for production or safety. For instance, at home I only replace my light bulbs when they fail, but there is no way that I would run the tyres of my car until they failed. Of course, things can and do fail, no matter what the strategy, and in that case, the goal is to fix crucial defects as soon as possible. So, run to fail is not the greatest maintenance strategy for important equipment items where failure has a consequence. The next strategy level is preventative or planned maintenance. Here, the idea is to perform regular maintenance on equipment in order to prevent failure. This is most likely done on a calendar basis or based on plant usage. For instance, my car should be serviced every 2 years or 20,000 miles. In this way, the maintenance can be performed when it is convenient to me, within a tolerance, and sometimes can be done whilst the machine is operating. The downside of this strategy is twofold. Firstly, you may be performing maintenance more often than is necessary, plus the fact that the maintenance itself may cause issues. Often things have gone wrong with my car after it has been serviced. The service itself has made the equipment slightly more susceptible to problems. So, preventative maintenance on a routine basis may prevent most breakdowns and keep the plant running longer. But it's a rather crude method, and we may be performing maintenance more often than we have to. What we would really like to do is to predict when each equipment item is going to fail, and just before that point, perform the preventative maintenance at the right time. To do this, we must monitor key sensors such as temperature, vibration, flow, deterioration, usage, looking for indications of failure, and using these and indicators from other equipment, either on your plant or others, to give a greater knowledge of what is happening in order to predict when a failure may occur. The more intelligence we can gather, the better. And these days, more and more equipment comes pre-built with control and instrumentation sensors and may be connected to the internet. The term is Internet of Things, to enable the intelligence we gather to better manage the plant. Here is a typical consultant's diagram, which indicates how operational costs will fall as your organisation matures from a mainly run-to-fail and preventative maintenance strategy into a condition-based or further into a predictive maintenance strategy. However, there is a cost to do this. An investment in people, processes and technology in asset management is needed to achieve these benefits. And the strategy for each type of asset should be proportional depending on the criticality of the assets. A mature organisation will employ a range of strategies, and in doing so will move from considering asset management as a cost on the organisation to considering it as an investment. Finally, I'm going to talk a little bit about my favourite topic when it comes to asset management. There are consultants who will insist that good asset management can be achieved with efficient processes. There are others who will insist that the people aspects of any project are the most important. Software salesmen will convince you that you need to invest in technology. Buy our system and all your troubles will be solved. However, they are all wrong. Whilst these are important aspects to building a good asset management environment, the most important thing to consider is data. People who know me know that this is a passion of mine. You cannot run an efficient maintenance management regime whilst all your data is wrapped up in documents and is not readily available to you. Data about the asset itself, its functional requirements, where it sits within the system, the installed equipment, the type of equipment, data from the manufacturer, the bills of material, the type of equipment, where it is. We spoke earlier about the criticality, the safety-related data, plus any specific attributes related to the type of equipment, plus the condition data we spoke about earlier. This is the data about the assets. What about the data related to the topic we have been talking about today, maintenance management? In many organisations, I see maintenance management data wrapped up in documents, O&M manuals, maintenance instructions, etc. Materials data, tools, instructions, labour, safety, resources, plans are either locked away in documents or in disparate systems that don't talk to each other. There needs to be an investment in data to move from a document-centric or IT system-centric environment to a data-centric way of working. Well, I hope you found that as interesting as I did. If you did, then listen out for the other videos that I am producing. Finally, I'm going to leave you with a short safety message. I produced a pocket-sized booklet on developing a safety culture for the nuclear industry. How do you communicate safety messages to your staff? Why not commission a safety booklet for your own workers?